Welcome to the Rocky Mountain AI Interest Group. The following presentation, AI Robotics, took place on November 12th, 2025 at the SMEAD Aerospace Engineering Sciences Building on CU Boulder campus. The event included an expo with a variety of demonstrations by area robotics enthusiasts, educational institutions, and tech companies. Presentations were then made by Max Conway, a PhD student at CU Boulder and the founder and CTO of Real-Time Manufacturing, and Dr. Mohammed Mahour from the University of Denver and the founder of Dream Face Technologies. Chapter markers are provided below.
I'd like to introduce our next speaker. Max Conway is a PhD student at University of Colorado Boulder, and he's founder and CTO of Real-Time Manufacturing. He's going to present Golem, Humanoids for Manufacturing. His talk will cover the state of the humanoid market, humanoid case studies, challenges unique to the humanoid form factor, and the solution provided by Golem. He will discuss his work funded by the Department of Energy's ARPA-E branch to autonomously disassemble EV batteries for recycling. Finally, he'll do a demo of the Unitree H12 platform's walking and control capabilities, as well as discuss the current limitations. Please join me in welcoming Max Conway.
Hi, so I'm Max, and thank you to Dr. Mahour and to Dan and the rest of the Rocky Mountain AI Institute for having me. Today I'm presenting Golem, Humanoids for Manufacturing. So in manufacturing, workforce is a top challenge. Even when there's economic uncertainty with things like tariffs and trade wars, workforce remains a high priority challenge. So a natural solution to not meeting your workforce demands is to have automation. And so automation can take many different forms, one of which is the humanoid. So the humanoid is a great form factor for many reasons. Like with Ryan, there's lots of social and emotional connections we can form easier with the humanoid form factor. But the humanoid form can also integrate into existing human spaces. So instead of having like a robot arm or a robot cart where you need a specific path or a clean work cell for the arm to be in, you can just have the humanoid integrate directly into those spaces. The humanoids are also multi-purpose. So instead of solving just one problem, the humanoid can work on a problem and then go to another station and solve a different problem, instead of just having one tool, one end effector, where it puts caps on toothpaste tubes or something. So humanoids are a very challenging platform. Other robot forms are also challenging and have actually given us a lot of insight into how we should solve these problems. So from mounted arms, we learned things like manipulation and vision and object detection. And from wheeled mobile robots, we learned things like path planning, SLAM, and learn from other problems. But with the humanoid, we have to kind of take all these solutions from all different types of robots and combine them into one platform. And additionally, we have the challenge of balance, which the robot dog, which many of you have probably seen, also has, but with just 2 legs, balance becomes a little bit harder. So humanoids have tremendous promise. Many of the visionaries that we all are familiar with and have our own opinions of state that humanoids are going to be everywhere. People think humanoids are going to be in the house, they're going to be doing your laundry, they're going to be taking your kids to soccer practice, they're going to be cooking your meals. But that's not actually where we are right now. So just real quick, is anyone familiar with the Gartner hype cycle? So Gartner is a technology advising company that has this great kind of flow chart that they put all technologies into. So a technology starts with this innovation trigger when we first have this technology and everyone's really excited about it. And then we reach the peak of inflated expectations where we're overpromising what this technology is going to do. This technology is going to solve all of our problems. Some of you may be able to think of technologies right now that are at this peak of inflated expectations. And then once we realize, okay, maybe we oversold this technology, then we enter the trough of disillusionment where nobody believes in the technology and it's not going to do anything, before we reach the slope of enlightenment and plateau of productivity where we can actually start applying this technology usefully and consistently. So humanoids, Gartner puts working humanoid robots at the innovation trigger, and I agree with that. They put it 10 years out. I think that's a reasonable conservative judgment. But where we really want it to be is at this plateau of productivity. And so where we believe that's going to be is at this for dull, dirty, and dangerous tasks. So these are tasks that are dull, they're repetitive, you can get like repetitive stress syndrome, or it's just not mentally stimulating. They're dirty, you're working with mud or any other kind of material that you would rather not work with. You can think of plenty of those in healthcare contexts. And then dangerous tasks, things like battery disassembly, or we all think of bomb disposal, or maybe medical waste disposal. So these are all things that the humanoid will actually be pretty good at, is these dull, repetitive, or dangerous tasks. So approaches right now, there's really two dominant approaches, teleopt approaches and learned approaches. So a lot of you probably saw Neo. So Neo was kind of announced and available for purchase in the last 2 weeks. And so this is a robot that is in your house. It can do tasks, but this robot is teleoperated. So there's someone somewhere in the world controlling this robot. Now, for me, that brings up a lot of privacy concerns. It's less secure than having a stranger in your house, because it's a stranger that you don't know and you would never recognize, and you just trust that this company has hired the right person. Now, I'm not sure what the company would say in response to that. I'm sure they're taking some privacy protective measures, but it's a tough sell. And then Tesla and Figure are taking more end-to-end approaches. So they are taking kind of the language model approach, where they take all the data they possibly can collect and they train models to complete tasks. So with Figure, this is putting laundry in the laundry machine. With Tesla, this is natural language instructions that the humanoid can do. But these approaches have some, my next slide, there we go. So these kind of end-to-end approaches, where you take all the data, you possibly have many different sets of data, and you just train your neural network to produce probability distribution of actions, has some drawbacks. These drawbacks include the fact that they're probabilistic. So if you have an action with a 1% chance, that's pretty bad. That's okay for one time step. But if you're taking millions of actions and your bad actions have a 1% probability, you have a very high chance of eventually taking a really bad action. These kind of networks are also very difficult to explain and sensitive to kind of distribution shifts. So if you train your robot policy, particularly in your house, it might not train or transfer to someone else's house. And so this is a viral video that many of you probably saw, where they took actually the H12, the same robot we have, and they trained it out of, or something happened out of distribution, and the robot had this high torque incident. And so if something like this happens in your house, you will never buy a humanoid again. If this happened at your work, you never buy a humanoid again. So trust is a really important factor here. And yeah, like being able to trust these robots is really important. And these end-to-end policies don't necessarily foster the trust we're looking for. So yeah, this is super dangerous. And it's funny, but it's also something to be concerned about. And so we introduced our Golem approach. So our Golem approach follows more traditional software engineering practices, where we basically have modules, and each of these modules is developed independently and tested to be very robust, and then we can combine our modules to get greater behavior. So we have a perception module, where that's really like your eyes, where you can see things, you can sense things, you can be aware of your surroundings. And then we have our manipulation module, which I think of as between the neck and waist, where this is your arms and your hands and how you grasp and manipulate objects. And then we have our mobility module, which is how you balance and navigate the world. And so all of this is designed and optimized for NVIDIA hardware on the Jetson Thor, and intended to be deployed in work cell manufacturing environments. So environments where you have kind of stations and inventory flows between stations before the inventory is complete. And all of this is planned to be open sourced and made available for modification and customization. So our perception module, our robot has 2 sensing modalities. We have 3 of these cameras here. Can you see my mouse? Yeah. So 3 of these Intel RealSense cameras that provide not only RGB images, so camera typically takes an image with pixels. Each of those pixels has a red, green, and blue value, but it also has a depth value, so you can tell how far away a certain pixel is. And then, so we have 3 of those. We have 1 on the head and then 1 on each wrist that lets us kind of learn more about objects as we move closer to them. And then we also have this this little globe-looking thing on the bottom of the head, that's a 360-degree LiDAR. So that shows you the world around you. That doesn't give you color, but it does give you distance. And it gives you a distance at a much finer resolution than the depth camera does. So you can see with the RGB cameras, we can get these object detections. So we can get the drill and we can get this kind of 3D representation of the drill. And with the LiDAR, we can create maps, and we can use those maps later in the mobility module to navigate. And so this is work currently being done in the Corel lab at CU Boulder by Chen and Jensen, both awesome people to work with. And so we have the manipulation module. So the manipulation module is how we move the arms and move the hands to get tasks done, really. And so we're able to open drawers, open doors, we can pick up objects, and yeah, that's really how we interact with the world beyond just moving and seeing. One existing effort we have is these touch sensors. Hopefully some of you got to see them today. Artemis was showing them in the lobby. And so these are sensors that give you sense of touch and force. So if you think about screwing in a screw, that's really a forceful interaction. You can use your eyes to align the screw to the screw hole, but you really feel when that screw threads, and you can, that's a forceful interaction, and you just won't get that from vision. And so this is also work done at CU, being supported by Artemis, Xuan, Yutong, and William, who are also all great to work with. And so finally, we have our mobility module. And so this is our learned module where our robot learns to balance and navigate. So don't all stand up, but when you're standing and you move your arms, you only have so much range you can go to. But if you can kind of move your pelvis or you can take a step forward, then you have a much bigger range of where you can manipulate. So it's important that our mobility module can function regardless of what the manipulation module is doing. So we start in simulation with robots that don't do anything. They just fall. And by optimizing some kind of reward function, we can get robots that stand and they balance and they can move their arms, and no matter how they move their arms, they stay standing. And so we can combine that on our actual robot with our mapping system from the perception module to get autonomous localization. So here you can see the map on the right and the robot on the left, and the robot is moving through the map, and it's pretty confident about where it is and how it's moving, and then it comes to a stop when it reaches its goal. And so all of this is intended to kind of function in these work cell environments. So a typical work cell environment has these different stations, right? You have some inventory, and that inventory gets processed into a product, and that product gets packaged and shipped off. But if you have a labor shortage, then it's not exactly clear, or it is clear, that you're not making the use, you're not maximizing your manufacturing system. You could get more out of your manufacturing system if you had more labor, right? So if there's only one person who has to move all the inventory from inventory to station 1 and from station 1 to station 2, there's going to be downtime because that person can't be everywhere at once. So by using Golem, we can kind of automate this transport, right? It's not a very difficult task to push a cart or to move an object. And so, yeah, by using Golem, we can increase the throughput of these manufacturing environments to basically increase the output of the manufacturer. So our first case study here is battery disassembly. This is being worked on by Zach and Stefan, also at the Corel lab. So what we have here is this is a Hyundai Ioniq battery that sits in a car, right? So the Hyundai Ioniq's an electric vehicle. And so this battery is full of valuable material, valuable rare earth, like lithium, nickel, cobalt. It's an aluminum case. And so even when the car is at the end of its life, we still want to recover all of this material and put it to use either as a power storage object or just to recover the rare earth. And so this is work with the Department of Energy. And yeah, we use a humanoid, human arm team here because there are some things that the humanoid's not very good at, right? The humanoid has to balance while it moves its arms. The humanoid has to, if the humanoid were to do this task entirely by itself, it would have to use some kind of screwdriver or drill. But by using the arm, which is really good at screw removal, we can kind of get the best of both worlds, where the arm will remove all the screws, and then the humanoid can take the screws and sort them, and then the arm can remove all the copper wiring and bus bars, and then the arm can take those copper wiring and bus bars and deliver them to their next station. And so we get a better throughput, and we can disassemble more batteries faster. So one of our partners is Serba Solutions. So Serba Solutions is doing battery disassembly, and their solution looks something like this. They have a human and a robot arm team, and so the battery sits on a conveyor belt, and this arm is super dangerous. The human should not be near it or risk collision with it, and so the battery has to move back and forth between the human operator and the high voltage battery. Yeah, these batteries can have like 800 volts, more than enough to harm a person. And so by introducing Golem, the humanoid can be close to the arm. We don't care as much if the arm collides with the humanoid, we care a little. But we can reduce the number of times that the battery has to move back and forth on this conveyor belt to get just better throughput, recycle more batteries, put more rare earth back into the market. And the human is still needed for certain tasks, but they can supervise more stations. Their role becomes much more supervisory and less of these kind of dull and dirty and dangerous tasks where they're taking apart high voltage batteries the same way every time, every day. And so they can instead kind of supervise and keep an eye on the robots and make sure everything's going well. Our second case study is an industrial printer. So this industrial printer prints books, and the robot arm scoops off the books and palletizes them. So there's a pallet next to the robot, and the arm loads up the printer with the books. But when the pallet is full, there's downtime, right? And so somebody needs to come and replace the pallet with a new pallet, move the old pallet somewhere else, so that the printer and the book can, or the printer and the arm can keep doing their job. And while the pallet is full and it hasn't been cleared, then the arm and the printer are just idle. They're not doing anything. And so by using the humanoid, we can move the pallets around, right? We can get more uptime from our printer and more uptime from our robot arm by kind of automating this process so that there's less downtime with just full pallets waiting to be cleared by laborers in a labor shortage. So that was Golem. We are taking a very standard software engineering approach to build a perception, manipulation, mobility module. All of this is intended to run on NVIDIA hardware, make use of their fast floating point operations and tensor operations, and to be deployed in work cell environments. We're excited to open source this to the world and see what how other people will modify the system and improve it. Yeah, thank you. And so, yeah, we're on LinkedIn. If you guys want to follow us on LinkedIn, we'd really appreciate it. Oh, and so I have a robot demo, right? So this is the Unitree H12. This is a robot that comes from China. It's really one of the only ones you can buy. Unitree is very dominant in the market. They're, as far as I'm aware, really the only humanoids that people are buying and developing for. But it's really cool. This robot cost about $120,000 when we bought it, and that was before tariffs and trade wars. So add your tariff and trade war price to $120,000, and that's what it would cost today. But the idea is that prices for these will go down as they continue to release and are made more efficient, made faster, made better. Then they should kind of continue to drop in price. I think the latest one from Unitree, the R1, is very small. It's probably up to my hip, but that's a $5,000 humanoid. So you can buy that pretty effectively. Not maybe everyone, but companies and research groups certainly can. So people love the Wave, show pleaser. But yeah, this is the humanoid. It walks, it's pretty loud. I'll walk it kind of through here and you can all kind of hear. So the white noise is the fan. You can hear the fans blaring. And then you can also hear it stomping. So we work on kind of the second floor. And so there's a group below us, and they definitely hear when we walk the humanoid around because of the way it just stomps. I think for them it sounds like we're doing heavy industrial work. But yeah, this is a super cool robot. This is the same one we saw in the video kind of freak out. But yeah, so hopefully we won't get any videos like that today, although I would love to go viral. Yeah, this is our G1. It's super interesting to work with these. People all react to them very differently. The social science of these is very important because people respond to them differently. It's very interesting. When I do the wave, some people are inclined to wave back, some people don't. It's very interesting how different people respond to this kind of humanoid form as a machine. So yeah, this is our humanoid robot.
So Max, I wonder if you could explain for the people that didn't see it, the demo. You don't have to do the demo, but just explain the demo where you're using the goggles and then it's replicating what you're doing.
Yeah, so I can pull up a clip of that. So what Dan is describing is teleop. So teleop is when someone else is controlling the robot. And so that's like how the Neo is doing it, is it's teleop. Somebody else is controlling the robot somewhere else in the world. But our robot can also do teleop. We can throw on an Apple Vision Pro. Let me just pull up the repo. So hopefully many of you are familiar with GitHub.
And then we'll do Q&A right after this.
Sounds good. So yeah, this is teleop setup. So this is more or less how the Neo company is doing it. Is someone somewhere in the world is wearing a VR headset or has some kind of controller, and they're using that to control the robot, and the robot can mirror your actions. So that was a demo I had in the lobby. I didn't run it for that long, so sorry if you didn't see it. But yeah, the teleop is super cool, and it certainly is an approach to getting stuff done with the humanoids, but I don't believe it to be the end-all, be-all approach. Yeah, thank you.
Well, thanks for showing that. Okay. Hello, everybody. Welcome to the Rocky Mountain AI Interest Group. If I could have your attention, we will start the presentation. First of all, it's amazing to see all of you here. Thank you for coming. Thanks. Our group has grown to over 3,000 members, and congrats to you guys. Okay, I want to talk. Oops, I'm getting a little bit of feedback. I want to talk a little bit about a couple robot things before we start. So let me thank Seshu and Jerome for robot transport. They're in charge of getting the main robot or the large humanoid to the event and back. So please give them a round of applause. So where are Seshu and Jerome? Could you guys raise your hand? Okay, Jerome, Seshu. So I talked to Seshu last week, and he said, I can help you transport the robot, but I work for the government. I'm on furlough, and if the government opens up, I can't transport the robot. So at the beginning of this week, I wrote to all my legislators, and I said, please open the government, but ideally not before Wednesday. So this is a thank you for our robot transport team. Special edition. And I have one for Jerome as well. So thanks to our special team there. Okay, so next up, did anyone see the XPeng video of this humanoid robot walking around? Has anyone seen it? It is so incredibly human looking, and it's really hard to reproduce the gait of a human. I saw the video and I said, there's no way, that's someone wearing a robot suit, which a lot of people did. So then the CEO had them cut the leg covering off this robot and show it is a robot, but the next comment was, no, that's a human with a prosthetic leg. So, also with AI video, you can't tell what's real. So We're still trying to figure out if that one's legit. The motion is absolutely stunning. Okay, then one final thing. We tried to get Tesla to send an Optimus robot, and they wouldn't do it. But there's a Tesla dealership in Superior that has just the brick robot. It's just like it's not a working robot, but we thought it would be cool to have that, and they still wouldn't do it. And so there was someone in this room that was helping us with that. Thank you. At the Tesla earnings call, they announced they're building a 1 million unit line, Optimus line in California, and another line in Texas to build 10 million units. And so Will Jackson, who's founder of Engineered Arts, that's the UK robot company that sent Amika here last year, that torso robot that we had. His comment on this was, I would suggest selling one would be a place to start, because they've never sold a robot. Will always has these really funny comments on the robot posts. Okay, I would like to thank our RMAIIG student board, Soren, Benjamin, Owen, Runel, Haima, Nabil. Nabil is the team leader and essentially set up this entire meeting. So don't thank me, thank Nabil. And the rest of the student board. They were all incredibly helpful. So thank you guys. I'd also like to introduce and thank our executive committee. If you're here, please raise your hand. So Bobby Hodgkinson, Phil Nugent, Bill McIntyre is right here. Uche, where is Uche? Right there. And then Susan Adams. Okay, so thank you to our executive committee. We have a distributed leadership model. If you want to make a suggestion, offer to speak, suggest a topic, reach out to any of us. It doesn't have to be me. Okay, I'd like to thank our sponsors. So we have 2 platinum sponsors, Brad Feld and Kamawaza, and then we have our gold and silver sponsors. Our gold sponsors, Bear Peak Technology Group, who also sponsored pizza tonight, and they're going to be speaking in a moment. Iterate.ai and KO Law, those are our gold sponsors. And then 5 silver sponsors, Colorado AI News, Chris Black Consulting, Herding Wolves, Intuos.ai, and Mutual Intelligence. If you're a sponsor, please raise your hand and we'd like to thank you. We also have 11 different special interest subgroups. So these are groups that go deeper on particular topics than we can cover at the monthly meeting. It ranges from AI and product to a Fort Collins group, Denver group, Women in AI run by Susan Adams, AI machine learning engineering, and so forth. So if you're interested, I'll give you a link. You can connect with any of these groups. So let's run through, we don't have a ton of time, but I'd like to just run through some of the upcoming meetings. So November 18th, AI and Product is going to have a meeting at Canyon Theater at the Boulder Library. And there's a QR code here if you're interested. They're up to 1,142 members. I think they're going to outgrow our group pretty soon because they are growing so incredibly fast. Right. So that's the AI and Product meeting coming up. Women in Colorado is doing a meeting Wednesday, November 19th, 5:30 at the Kiln in Boulder, called Cash is Queen, Financial Agency, Conscious Capital and Women's Power. And there's a QR code for more details, or you can use the general RMAIIG link tree to connect with the Women in AI group. Okay, next, AI and Marketing. This is tomorrow morning, 8 a.m. Everyone is back from this big AI marketing conference, and they're going to share insights from that. So that's 2000 Central Ave. There's a QR code if you're interested in attending that. That's the AI and Marketing run by Jason Cormier. Okay, next we have the Fort Collins group. that's going to be meeting on November 17th and December 5th. 1995 is still calling and they want their penguin back. So that animated GIF is for you to enjoy. Andres, can you raise your hand?
Right here.
Okay, he runs the Fort Collins group. So here are the upcoming meetings, QR code if you're interested, or talk to Andres after the meeting. Okay, ethics, safety, and AI. So Chris and Ken, could you raise your hands? So Chris and Ken run this group, talk to them. They have a meeting on November 17th, embodiment and ethics. Should robots have rights or roles in human care? And we're going to hear a lot about that topic here momentarily. And then December 15th, there's going to be another meeting, and they'll decide that on the next meeting. Okay, so this is the link tree. This links to all the RMAIIG resources, our videos, our Slack community, the meetup page, the shared calendar, all of those different subgroups that I mentioned. So shoot take a click through on this QR code if you're interested in connecting with the RMAIIG resources. Okay, this is our list of upcoming meetings. December 17th is AI for Good. That's the only one we have scheduled because there's sort of a lag in scheduling this room. We have not scheduled the spring dates for this room. But these are some of the upcoming topics that we're considering. How not to be replaced by AI, quantum, one on startups, energy and the environment, and a meeting on voice tech. And in terms of AI for Good, let me have, is Phil here? Where is Phil? I'm going to have Phil just say a few words about speakers for this meeting.
All right, how's everybody? So two guys walk into a bar. No, AI for Good, I talked about this last month, and I'm talking about it again. Not that we don't have a good bunch of candidates, but I'm always looking for more. It's the American way, is it not? So that apart, or that aside, we are still looking for some good AI entrepreneurs, startups, experts, academics. If you are in what's, I think, frequently thought of as AI for social good, I would encourage you to reach out to me. You can see my email address. I'm on LinkedIn, always happy to connect. And it's coming up, what is it, 1 month and 5 days? Right, 1 month and 5 days. So we still have time. We've got some awesome candidates, but would love to have you guys and just, say hello, right?
Awesome.
Because even if you don't make the December meeting, there's always next year, and we're always looking for, all of us at RMAIIG are looking for great companies and entrepreneurs.
Thanks, Phil. And thanks for setting up that meeting. We appreciate it. Okay, I would like to thank our pizza sponsor, Bear Peak Technology Group. They are here. They're going to say a few words. Where's our speaker? Here we go, John. John, okay, thank you.
Thanks, Dan. So hi, my name's John Eckhart. I'm actually a Colorado native. I don't know if there are any of those in the house. Raise your hand if you're a Colorado native. Kick ass. Welcome to the rest of you guys. So I grew up in Denver, ended up here in Boulder for undergraduate, actually was an aerospace engineering undergraduate at CU. We did not have this facility. We were up on more or less the main campus at the quote unquote old engineering center there. They used to call it the ITLL. I was talking to someone, maybe they don't call it that anymore, I don't know. But anyway, graduated from there with a double degree in aerospace engineering and computer science. And then this is right at the .com era blowing up. So of course I got straight into technology startups and I did 4 of those. And that was pretty much the first 20 years of my career was going through product-led startups, that 2 of which accelerated and became exited through acquisition, and 2 of which are still around today, surprisingly enough. Batting 500 or 1,000, depending on which number you want to disbelieve. So anyway, 5 years ago, I started the Bear Peak Technology Group as a vehicle to bring sort of my track record and my network and my know-how for getting products out there and for getting companies started to small and medium-sized businesses wherever. A lot of our clients are right here in Colorado. We love working with Colorado companies. We like being in person, surprisingly enough, in the world of AI and virtual. I think that's actually important. And anyway, that's who I am, and that's who the Bear Peak Technology Group is. We're super proud to sponsor RMAIIG this whole year as one of the gold level sponsors. I love just sort of the academic and free thinking that happens here, and how we're looking at AI in all of these different realms and disciplines. And it's just such a formative and important time to be doing that, right? And so I think it's really important that it comes, of course, in the form of legislation and everything else that it needs to come in the form of, but ultimately it has to come from us, right? The people. And anyway, so we're just super supportive. So I hope you enjoyed the pizza. What our company does a lot of is web and mobile applications, data lakes, and everything in between, integrations, systems integrations, and things like that. So if you're a designer, if you're a programmer, we might have projects for you. And if you know somebody that needs an app or something, we do that type of work. So thanks for having us. Hope it's an awesome night.
Thank you, John. Thank you very much, John. John supplied 40 pizzas, and they lasted at least an hour and 15 minutes until they ran out. So you guys know how to eat a lot of pizza. Okay, we always take a minute to announce any job openings. Does anyone have a job opening where they're hiring an AI person? Hiring anyone in AI? Okay. So keep your hands up. And if you guys would email me, dan@rmaig.org, I will put this on our Slack channel.
Hello, everybody. I'm Chuck Stovall, CEO and co-founder of Navflex Robotics. We're based in Thornton, and we're moving right up by the Topgolf, so it'll be easy for y'all to come. We are greatly expanding our team, and we do autonomous software. So we load and unload autonomous trailers here and in Europe and in Asia. And so we're looking for growing our team, entrepreneurs that want to be part of our company and grow with us. We're hiring now.
Awesome. Thank you.
Can you say your name and your company's name?
Oh, yeah. Chuck. My name is Chuck. If anybody wants to email me, it's Chuck@Navflex, NAVFLEX.com. And that's what we are. It's Navflex, NAVFLEX.
Cool. Thank you, Chuck. If you send me an email, I'll put that on our Slack job posting. Okay, Philip.
Yeah, my name is Philip Ogren. I work at Oracle. We are looking for senior research scientists in recommender systems and machine learning. You can contact me, philip.ogren@oracle.com, philip.ogren. We're looking for senior researchers. Thank you.
Thank you, Philip. If you email that to me, I'll put it on our Slack channel. Anyone else? Last call for, we have more job openings.
Hey guys, how's it going? I work at Focus.io. We are looking for lead AI engineers. We work in LangChain, LangGraph mostly. So if you know the tech, if you've used it, let us know. It's Focus.io.
Awesome. If you send me an email, I'll put that on our Slack channel.
Thank you.
DZ.
Yes. Hi, Steve, DZ. Work at a company called Sprinkler, which is a unified CXM platform, which means nothing to anyone here. We are looking for a AI forward deployed product manager, which basically means a field level product manager within the AI space, helping customers understand how they can use our AI, what they're trying to do with our AI and all that fun stuff, and then also help develop the product in the future. So it's a large global SaaS environment. Thanks, bye.
Cool. Yeah, thank you so much. Anyone else? Other jobs? Okay. I was also given a job posting list from a company called Constructured that's hiring a product manager, an AI builder, and 1 or 2 interns. I will post this to our Slack job community. I'll have this sheet of paper. If anyone's interested, you can take a picture of that. And that's the company is AI Driven Insights. Gary McBride is the managing director. Gary at constructured.com. So if you're interested, see me afterwards or check our Slack community.